question. State and explain Coulomb's law. Coulomb. Coulomb's law. Where? In electrostatic. In electrostatics. Usually they may ask for 4 marks or 5 marks. Let us see how to start with. First you write statement. Now consider two charges Q1 and Q2, two charges, 2 point charges, right? 2 point charges kept at a distance of D. D is the distance between them. Some textbook they'll write R. Anything. R is the distance between them. Now this is a positive, there is a force of repulsion, right? If it is both are positive. Both are negative, force of repulsion. It is positive and negative, force of attraction. Therefore, the force of attraction or repulsion. See, negative represent attraction, positive represent repulsion. Force of attraction or repulsion is directly proportional to product of the magnitude of the this is important, magnitude of the charge, and inversely proportional to square of the distance between them. Square of the distance between them. This you have to write in a sentence. Statement. That means what? Force of attraction or repulsion, is it not? Force of that means the force of attraction or repulsion between the two point charges is directly proportional to product of the charges. Charges you should not write. Magnitude of the charges. Magnitude of the charges directly proportional to the magnitude of the charges. Magnitude what charges? Point charges. Okay. And inversely proportional to square of distance between them. Distance between them. See why I am writing like this again and again. See, student, magnitude they don't write. Magnitude of the point charge they don't write. They don't write point charge. And inversely for square of the distance between them. No problem. Force of attraction or repulsion. Attraction is negative, repulsion is positive. For the statement, they'll give 1 mark for this. Okay. And every college, every school, every places, the statement all the students will tell correctly because it is the beginning of the portions, right? First 2 chapters they will study very well. For statement 1 mark you'll get. Then you have to write the diagram. What about the direction of the force? The direction of the force is along the line joining the two forces. The direction, explain they gave now, that is why direction of this force. This force is along the line joining the two charges. Line joining the two charges. Okay. What is explanation? This is statement. Next, explanation. Set explain. No? Let Q1 and Q2 be the magnitude of the point charges. Point charges kept are separated by a distance r, from Coulomb's law. Force is directly proportional to product of charges keeping distance constant, and force is inversely proportional to square of the distance keeping Q1 Q2 constant. Combining them, what will get? Force is directly proportional to Q1 Q2 by r square. Therefore, force equal to some constant Q1 Q2 by r square, where such that K is equal to 1 by 4 pi epsilon naught, where epsilon naught is the absolute permittivity of free space, and 1 by 4 pi epsilon naught value is equal to 9 into 10 to the power of 9, right? 9 units. Therefore, F is equal to 9 into 10 to the power of 9, or F is equal to 1 by 4 pi epsilon naught Q1 Q2 by r square. This is in vacuum. Okay. Now state and explain. For explanation, whatever you write, this is for 2 marks they'll give. For explanation, 2 marks they'll give. Whatever, writing the sentence. Up to this full. Then what about another 2 marks? 5 marks, no? For 5 marks, limitation of Coulomb's law. This law applicable only for point charge. This law is applicable only for point charges. Understood? And see, inside the nucleus, the distance is 10 to the power of minus 15 meter. 10 to the power of minus 15 meter inside the nucleus. If the distance here inside the nucleus is called 1 Fermi, this Coulomb's law is not obeyed. That means inside the nucleus there is only attractive force. That means 1 Fermi or 10 to the power of minus 15 meter. That means this law is applicable only for the applicable when the distance between the point charge is greater than 10 to the power of minus 15 meter or 1 Fermi. Okay. This one, this is for 1 mark. Now we have gained 4 marks. Suppose they may ask define unit charge. Define unit charge. What is the unit charge? 1 coulomb, right? 1 coulomb. Suppose Q1 is 1 coulomb, Q2 is also 1 coulomb, R is the distance, that is also 1 meter. Then both are positive charge, say 1 coulomb plus plus. What is the force of repulsion? You calculate. Therefore, force is equal to 9 into 10 to the power of 9. This is what? 9 into 10 to the power of 9, correct? Q1 is what? Q1 is 1 coulomb, Q2 is also 1 coulomb, R is what? 1 whole square. The force is what? 9 into 10 to the power of 9 Newton. That means 1 coulomb, if you keep at a distance of 1 meter apart in air or vacuum, it would repel with the force of 9 into 10 to the power of 9 Newton. Therefore, for this 1 mark, they'll ask you, very, very important. Define unit charge. How to define? 1 coulomb of charge which repel with another identical charge with a force of, what is that force? 9 into 10 to the power of 9 Newton when placed at a distance of 1 meter in free space. Therefore, definition: unit charge, that is 1 coulomb. 1 coulomb is the charge, right, which repels another identical charge with the force of 9 into 10 to the power of 9 Newton at a distance of 1 meter in free space. This is for 1 mark. Therefore, if you want to gain 5 marks, you have to write that much detail. State and explain Coulomb's law in electrostatics. The force of attraction or repulsion between the 2 point charges, directly proportional to the product of the point charges, okay, and inversely proportional to the square of the distance between them. Got it? Force of attraction or repulsion is directly proportional to product of magnitude of the charges and inversely proportional to square of the distance between them. Then what? The direction of the force is along the line joining the charges. Explanation, right? Q1, Q2 kept at a distance R, D you don't want R. Force is directly proportional to product of a charge, R you can keep it. Similarly, force is inversely proportional to square of the distance, charges are kept constant. If you equate, you'll get it. K is what? Proportionally constant. That is 1 by 4 pi epsilon naught. This value is 9 into 10 to the power of 9. Then you can use it for the problems. What are the limitations? It is applicable only for point charges, and it is applicable only when the charges are kept more than the distance of 10 to the power minus 15 meter. Then unit charge is what? Is that charge when you kept a distance of 1 meter from equal and similar charge would repel with the force of 9 into 10 to the power of 9 Newton in air or vacuum, whatever it is. Okay. Now, there are different vector forms are there. All the things we'll do in the B level. This is only for A level. Okay. Thank you.